Hello and welcome back. What you're looking at here is an earlier iteration of my engine, and what I want to draw your attention to is this left panel here called an Asset Library Viewer. And today what I want to focus on is creating this concept of an asset library. And usually what I use the asset libraries for is to track assets that are being used in the current scene. For example, I might have a texture library here that has all of these textures that are currently loaded and potentially in use within the scene. For example, the tile map here, you can see I've got some information about the texture. This in particular happens to have subtextures as well, so I've got that exposed here. The full size of the image, the tile size per tile, and the path of where it is sort of relative to the project. And then an image of the actual asset itself, right? You can see the same for items. I have a bunch of items, some generated rooms, which is just another asset that is currently used. And then if you look at shader library, I have shaders here that I could look at as well, like the vertex shader or the fragment shader, for any of these sort of different shaders that I might have available to myself in the engine. So this is what we're going to focus on today, which is bringing this concept of an asset library over to our iteration of the engine. So if that sounds interesting, please stick around. As always, remember to subscribe and give me a big thumbs up, and let's get into it. So asset libraries are going to be sort of at the core of Hippo, so I'm going to add it to core here, and we'll just add an asset library.h. Now, in the earlier iteration that I just showed you, asset libraries were actually owned by the engine itself. So the Hippo engine owned an asset library for textures and an asset library for shaders. I think I want to do something a little bit different here. I want asset libraries to be sort of these reusable components that do work on a specific type of asset. And anybody can own an asset library, right? So maybe one scene in particular owns an asset library for the textures that it cares about for that particular scene. And maybe the editor itself has its own asset library for assets that are required within the editor. So I want to make it a little more flexible in that regard. So I'm actually going to make this a templated class. And again, the idea is that we could have an asset library of any type, right? And it's really just a way for us to map a key, meaning probably we'll use strings here for a name of the asset, and then a value, which will be an underlying T type. So it could be a texture, it could be a shader. So let's start with a couple things. We'll have include string because that will be our key. And then we'll store everything in an unordered map. We use unordered maps because they're O of 1 or constant time lookup when you query the map for a given key. And then we'll also include memory because it'll be an unordered map of strings to shared pointers to the underlying type. So let's create that now. It'll be a std unordered map of std string to std shared pointer to t. We'll just call this massets. Now again, because it's a templated class, everything goes in the header file. So let's just do an asset library. The constructor will just be the default constructor. And I don't do this for all my classes. I don't know, sometimes I forget, sometimes I don't do it. But thankfully with most of these classes, the default constructor will be empty anyways. And now I plan to use asset libraries primarily for assets that are stored on disk that we need to load. So we'll have a load method. That'll take a constant string reference name and then a std shared pointer to the asset itself, asset, right? And this can just add the asset to the map, right? So massets at name equals asset. Now we might want to check if this asset already exists, and actually we could probably do that in its own function, right? So bool exists. And this will just return if massets.find of name does not equal massets.end, right? Simple. So in here we can just say if exists, then maybe we'll just warn, like we're about to override whatever you think is currently loaded in that thing. So let's just warn asset library load. There we go, and then we'll stop it anyways. Okay, perfect. Now we can also going to need a get, right? So std shared pointer to t get, and just return massets at name. Now, of course, we have to check if it's there. So we can just check if exists. Then we can return mAssetSetName. Else we can just return null pointer. And maybe we'll throw an error too here if it doesn't exist. So hippo error instead of warn. I haven't really decided what the threshold is for what constitutes an error versus a warn. I think I'll just throw an error. Asset not found, name.cster. Perfect. So now we have a load and a get. I guess we'll also want to delete just in case we want to clean stuff up halfway through our scene or something. So let's delete. So again, we'll just check if it exists. And if it does, then we know it exists. So we can say just auto it equals massets dot find name. And we can say massets dot erase name, or it rather. Right, and maybe we can also print out the remaining number of handles for the shared pointer, just so that you know if you're actually deleting the last one or not. So we could do that pretty quickly. Just if it-arrow second, which is the shared pointer, dot use count. If it's greater than 1, so we are already holding 1. So if it's greater than 1, it means this delete won't actually clean the shared pointer up. So we can just maybe hippo. I don't know if it's a warning. It's more of a just info, right? AssetLibrary delete remaining handles for assets. Boom, boom. And we'll do name.cster. And I guess we could keep this here. Auto use count. What's that? Just print it here. Now we might also want to clear. That will just massets.clear, which will clean everything up because we'll get rid of all of our shared pointer instances, which is good. And that's pretty much all we need for an asset library, right? The whole point is just to wrap this unordered map with a nicer API. But now what we can do is in main.cpp, where we currently have these three sort of standalone vertex array, shader, and texture. These are shared pointers to things that we can actually point to what we have in our asset library. So if we go asset libraries, let's include it, which is it's part of core. Oh, and I just saw hippo log and realized that I'm going to need to include hippo log here as well to fix that error that we fixed on the Mac side last episode, because these are inline and some of these might not like depend on templates. And anyways, we just need to include hippo log here. Okay, back to main.cpp. So yeah, now I can have these asset libraries. So core asset library of, let's say, graphics vertex array, and we'll call it MVA library. We can have an asset library for graphics shaders, mshader library, an asset library for graphics texture library. Now what we can do is actually like fill these in with various options, and then we can switch between them at runtime, right? So maybe what I'll do is I'll have like a initialize libraries method that can do sort of all of this for me. Even this MVA, like I don't want to set this, I want to create a standalone one that goes into the asset library, and then we can set MVA to that, right? So we'll just move all of this, the shader code, the texture code. Let's put these down here so I can copy these down. So basically all of these will go into this initialize libraries method, which we can put at the bottom. There we are. So first we'll initialize the vertex array library. This will be a std shared pointer to a graphics vertex array. Just call it VA. Let's make shared. And I'll just scope this so I can reuse the same names over and over again. And we'll just say this is VA Okay, so this vertex array has been created. It has a buffer of positions and colors, which we can get rid of now. Like we don't actually need this. This should just be positions and shorts for textures. Okay, so this will be a textured rect, right? Which has floats and shorts. We set the elements, upload, and now we can say MVA library dot load, and we'll call this a textured rect, and we'll pass in VA. Nice. And now we can have a non-textured version as well. So maybe we'll put that one first. So again, VA will just have positions, and it won't need a second attribute there. Same elements, same upload, and this will just be a rect. It literally just has vertex positions. Now onto the shaders. This will be similar, right? Because I don't need this test shader comment anymore. We're really going to start reading these from disk. I mean, we could do the same for rects. I mean, rects are whatever. It's a 2D engine. It'll probably just be a lot of this, textured rects. But shaders can definitely be on disk. Same with textures, obviously, which they are. But anyways, for now, we can have the vertex shader, the fragment shader. This will be std shared pointer to graphic shader. Now this has a set uniform, which we won't do. I was setting color. Anyways, we got to clean these up anyways. So this will be for the textured, which we won't have a color. So we have 3 positions, 2 texture coordinates with the vector vertex positions. No, we don't need any of that. Just UVs. We don't need an offset. Actually, do we still support offsets? Yeah, we do. Let's get rid of that because that was just more testing stuff as well. We'll keep model because we might want to move this thing around. And eventually, actually, we'll have to come back and add view and projection matrices when we do cameras. But for now, we'll just keep model. And yeah, we'll just put UVs in there. We don't need the position offset anymore. That's good. And then the fragment shader, we'll just take in UVs. Don't need color or blue. But it does have a sampler 2D, and it reads from that text sampler and doesn't add color to it. It'll just be a basic textured rect here. Okay, and then we'll create the shader, and actually, we don't even need to call anything on it, so we could even just say shader library dot load, and we'll call this again textured rect. We can have the same name, no problem with that. And then we don't need to, we can just do this. Make it in line here. Perfect. And I should probably name this shaders. Right, this is vertex array, this is shader. And then we'll do another one here that isn't textured, so it only takes positions. Doesn't need to pass UVs along. Good. Doesn't take in UVs, it just... Oh, okay, now this one will need a color. We'll just say call, and then maybe this one will take another uniform, so uniform. Actually, not a sampler 2D, just a uniform vec. I guess we're doing 4 call equals vec4 1.0. This would just be a rect that you can color. I guess that means we could have kept the color in down here as well, but it's fine. It doesn't matter. Okay, those are our shaders, and now for our textures. This we will probably want to make sure because we might want to call this on the texture before we load it in, so that's fine. We'll do I'll just call this text. So we're loading res/bro.ping, and we're doing that, and then we can say texture library dot load, and we'll call this bro, and it'll be text. Perfect. I think we need a second image just so we can load 2 things and swap between them. So maybe I'll just create a bro2. Call this one bro2. Let's just make his shirt have red on it. Okay. Save as bro2. Perfect. Now we have 2 rows. So now what we're saying is that here are all the resources we're loading when we are loading the editor. And now they're already loaded. So, I've read from disk for these 2 different files once up front. I've paid that cost of reading from disk, but now I can switch between them very quickly at runtime, right? So now that we've initialized the libraries here, we can actually start setting these our actual values. So MVA, we can just say equals MVA library dot get. We call it rect. Let's just start with rect. And then mshader equals MVA library dot get rect. And texture, we'll just say MVA library. And I just realized I'm copy pasting these in my head, but this is mshader library. And this will be texture library dot get, and we'll say bro. Okay, and that should be all I need now to just make a normal rect that should be colored white, I think, here. And we got some errors here. Shared pointer requires template argument list in AssetLibrary.h argument list. Oh, whoops. String. Oh, that's silly. All right, let's try that now. Okay, perfect. So we have a white rectangle. Now what I want to be able to do is very quickly just expose maybe some options here on the side to be able to switch between them at runtime, so we can see that it happens quickly with no issues. So in main, let's go down to ImGui render, and we can just let's put these together. We'll call this rect controls, and then down here we can have options. So we can just have some buttons to toggle between them, right? So if ImGui button, we'll say rect, then we'll say MVA equals, and the same thing we have up here. These 2, let's just take all 3 so we can quickly copy and paste. So the rect and rect, perfect. And then we can say ImGui same line to have a button on this, like whatever comes after this on the same line as the thing before it. So then we can say if ImGui button, we'll say rect textured. Then we can say rect textured. And now without same line, I can say on the next line, if ImGui button bro, same line, and then bro 2, bro 2. Cool. That should be a quick and easy way to switch between these at runtime. Now you can see, yeah, right, we renamed everything, so everything got reset to 0. Here, so now you can see we have our button. So rect should just keep us where we are. So rect textured, that crashed. Wonderful. Let's see what happened here. Asset library get asset not found rect textured. Okay, so we asserted because we tried to get rect textured from the asset library and then probably used it without checking if it was set properly, right? And yeah, just in the next iteration of the engine. So I probably called it textured rect, didn't I? I did. Textured rect. So let's go back up and do that. Okay, textured rect, there's my textured rect, bro and bro 2, easy to switch between them, though bro 2 I might have saved it without transparency when I just modified it, but the point is that you could see that these channels, yeah, it's a 3-channel texture instead of a 4-channel texture, so I saved it without transparency, which is why you see the white in the background there. But yeah, you can see that we paid for these costs up front, right? We uploaded our vertex buffers, we loaded our textures up front, and now we can very quickly and easily switch between them at will in runtime. Great. Now we have asset libraries that are populated with some data and we can change between them at runtime. But I would like to, as you saw at the beginning of this video, actually visualize these libraries. So what I'm going to do is here in ImGui render, I'm just going to add an additional spot here to visualize some of these asset libraries. So make it its own window. Now I guess to actually visualize this, we need to be able to get the contents of the texture library in full. So maybe if we just go back to AssetLibrary.h, we could just have like a getter to just return the entire map. So maybe here just a const reference to it, and then just say get all. So now I can iterate over the internal assets of this class from an external point, like main.cbp. So we can just iterate for const auto, it has to be const reference. We'll do kv usually for key value pair and then we can say this is the texture library dot get all. Perfect. And now within the texture library tree node, I'll have another tree node for each one of these actual textures, right? And I should, as I'm writing this out, I should pop these just so I don't forget. So just like begin and end, which actually I should do here as well. So I'm calling end, and then for tree node, I'm calling ImGui tree pop. There we go. And here the tree node will just be called kv.first.cster. Oops. So I'll ask for a graphics texture. And we'll use a raw pointer here, so I don't create a new shared pointer by showing them, and then our use count will be off. And if we have a valid texture, then we can show it, and then I guess else we can just do an ImGui text colored. We do a red color here. Invalid texture. KC, KV, .first.cster. Perfect. So now if we have a valid texture, we can show some data about it, and I think I'll do this for like every asset library. So within here, I can just define that I am, I think vec4. I will call it like data call for data color, and I'll just make them green. That way I can just keep reusing them in text colored instead of, I could even have an ImVec4 error call, which will be 1001. That way I can use error call here. And now here we can actually print some information about that texture. So ImGui, text colored, and we'll use our data call, American spelling, data call here. Use count will be interesting to see. So this will be colored, and then the next text will not be colored. So I'll do ImGui same line here, and then ImGui just a normal text. There we go. Now we can get some information about the texture itself, not just the usage of it. So like the size, the number of channels, and the path. So I'll just do this. Text colored. Here we'll say the size. This will be %d x %d. Perfect. Next could be the channels. We made all these getters. And then I think the path was the last one. Do we store the path in the texture? Yes, we do. Perfect. And the path will be %s textpath.cster. Perfect. And now let's actually show the image, right? So the image will have to be of a certain size. We can just say ImVec2 size and the size.x. I'll actually just do it this way. And then an ImGui image. And again, we'll use that void star and then int pointer t, because this is a pointer to our OpenGL texture. I think I have a get ID here, yep. And pass it the size, and then again we want to flip it on the Y because we're loading everything upside down. Perfect. I think that does it. That's all we really care about the texture. So let's just run this and make sure that we can visualize texture library properly. And UN32 to floats. Okay. Probably forgot to call something. So we asserted on the window stack. Tree pop. Oh, do we only tree pop if tree node was successful? So we begin and our end. Begin and our end. If tree node and then tree pop. Let's see what the this says. Oh, it doesn't give us any usage information. Tree node might. Yeah, there it is. So I'll just go to it so we can read it. Header. Yeah, tree node functions return true when the node is open, in which case you'd also need to call tree pop. So it looks like we only call tree pop if like internal to the if statement here. So if the tree node is actually opened, then we call tree pop. Okay, let's try that. Nice. So now we have our asset library viewer with a texture library within it. Let's just put this on the left here. And if I expand this, we have two images, bro and bro2. And here's bro. Use count is 2, size is 32 by 32 with 4 channels. And that's the path, and that's the image. Perfect. And bro2 should only have 3 channels, as you can see there. So there, that like white background question, we knew it was 3 channels because of our print, but if we didn't have that, we could easily visualize that here and see, okay, I see what's wrong with this image. It's only 3 channels. Awesome. Now, one thing I'm just noticing now is that we're naming our tree node with the name of the key in here, which is fine because we know they're always going to be unique. But what this doesn't account for is if I have a tree node or anything else that has the same name in a different panel or a different window. So what we should do here is just append something to this so that we can differentiate it, right? And this is just more ImGui specific work, but if I have 2 tree nodes both with the same name, the way ImGui works internally will get messed up basically. So maybe what I'll do is I'll just have a std string tempster equals kv.first, and then I'll say tempster, or actually I can just do kv.first, and then plus, and then if you do 2 pounds, that's how you can differentiate things that have the same name. So anything after 2 pounds will not show up in the name itself within ImGui. So now we can say 2 pounds, and then I just use like the window name, so like asset library viewer. This ensures that even if I have something called bro elsewhere, I wouldn't add this to that section because it's not within that window. And now we can just use tempster.cster here. Let's make sure that's still good. Perfect, good. Okay, that's great. I think maybe we'll also visualize the shaders, just because that also would be interesting to look at. So just after this, we can do another one, and I'll just copy and paste to start. This will be shader library. I could space them. These are just names. Yeah. And then we'll say am shader library.getAll. This will be shader library viewer. Sorry, this will stay asset library viewer. And then this, I'm noticing now, like now a shader and the texture can't have the same name because that'll be that. So maybe instead of, I'll say asset library viewer dot texture library. Just to be very, very explicit, dot shader library. Okay, that'll be your tempster, and then here we'll get a shader star. Shader. Else invalid shader with the name. Okay, and then in here, for shaders, I guess the thing we care about is use count is good, and then the actual shaders themselves, like the strings, right? Do we keep that in shader.cpp or shader.h? Do we store that? No, we don't. We don't store them internally, so let's do that here. Std string vertex shader. And then in here, in the constructor, we can just set them. Oops, there we go. And now we can just ask for them, right? So constant string reference, make it inline. Get vertex shader source. We'll do the same for fragment shader source. Perfect. Now main.cpp, we can actually use them, right? So maybe we'll do just another tree node. Vertex source, and then we can add, maybe we'll keep, actually I have the tempster here, I can just reuse it. So maybe I'll do that here. Tempster equals vertex source, double pound, and then we can just use this. And then we'll need dot, and I can add kv dot first here. Perfect, and then I can use tempster here. And then for this text, because I know it's like large text and it's sort of code, I can just use an ImGui text wrapped, which will ensure it's all properly wrapped. And then I'll just do a %s, and then shader dash arrow get vertex shader source dot cster. Perfect, and then we can do the same for the fragment. So we fragment source fragment shader source at 5. Okay, and now our shader library should have two things in it, rect and textured rect. You can see rect is used twice and textured rect is only used once. If I click the button to textured rect, you can see that swaps, right? So my main game is no longer using rect, it's using textured rect, which is good. The other use is internally to the shader library itself. And now we can look at the source. So if I expand vertex source, and yes, because I wrote these inline, they have a bunch of spaces in between them because I aligned them to the code indentation, but there they are. Once we start loading these from this, they'll be a lot easier to read. And that's asset libraries. That's pretty much all I wanted to get done today, so thanks again for watching. Please remember to give me a big thumbs up if you enjoyed the content, and I'll see you in the next video. Cheers.